Look closely at a single drop of human blood. Inside it is roughly 2.5 grams of iron, actively pumping oxygen through your veins. But tracing exactly where those specific iron atoms came from presents astrophysicists with a massive chemical puzzle. This data visualization shows the periodic table immediately following the Big Bang. The universe started out with only the lightest building blocks: hydrogen, helium, and a tiny trace of lithium. Notice every other box is entirely empty. Standard stars, like our Sun, act as basic cosmic factories. They take those initial light elements and crush them together, fusing them step by step into heavier materials. But that manufacturing process abruptly stops at iron. Here, stellar fusion hits a thermodynamic brick wall. It actually takes more energy to fuse iron than the reaction produces, leaving elements like gold, silver, and uranium completely missing. Yet we know these elements exist here on Earth. That means there has to be a localized event of unimaginable violence, capable of forging them outside the bounds of normal stars. To trace the origins of our own physical bodies, we have to identify this missing cosmic engine. The search takes us deep into space, to supergiant stars. These are celestial bodies massive enough to completely dwarf our own Sun, burning with intense heat and pressure. This cross-section diagram illustrates a delicate mechanical balance called hydrostatic equilibrium. Vector arrows pointing inward represent the immense crushing weight of the star's gravity. They are perfectly countered by outward-pointing arrows representing the explosive energy of nuclear fusion. That balance holds for millions of years, but eventually the star's core accumulates too much solid iron. Because iron requires more energy to fuse than it releases, fusion stops entirely, and the outward pressure drops to zero. Without that outward push, gravity wins the tug-of-war in a fraction of a second. Millions of trillions of stellar material go into immediate freefall. The star's outer layers collapse inward, plummeting toward the core at nearly a quarter of the speed of light. Because the supergiant can no longer fuse iron, its massive gravity turns from a structural asset into the weapon that destroys it. All of that infalling matter eventually hits the solid iron core, a surface so dense it refuses to compress any further. The material slams into that unyielding barrier and violently rebounds. This creates an intense outward-moving shockwave that tears back through the collapsing layers of the star. This particle physics visualization shows what happens inside that compressed wave. The extreme heat and density physically force individual atomic nuclei to slam together and merge. Physicists call this rapid neutron capture. In a matter of seconds, this high-speed pressure cooker forges the remaining heavy elements on the periodic table. A solitary supergiant collapse isn't the only way this happens. A dead white dwarf star trapped in a binary system can siphon enough gas from its companion to trigger a similar heavy element forging detonation, known as a Type A supernova. In either scenario, the violent death of a star serves as the universe's exclusive forge for creating the raw materials required for complex chemistry. When the explosion clears, the vacuum of space is left with a bizarre, ultra-dense remnant at the center of the blast radius, usually a rapidly spinning neutron star or a black hole. But the true legacy of the supernova is the expanding shockwave acting as a cosmic delivery system. The explosion blasts those newly forged heavy elements outward in every direction at speeds reaching 30,000 kilometers per second. As this high-speed shrapnel tears through deep space, it collides with massive, dormant clouds of cold hydrogen gas, thoroughly enriching them with heavy metals. Over millions of years, gravity pulls the enriched mixture together, condensing the gas and dust to form new, next-generation star systems and solid rocky planets. Those newly deposited elements, the carbon, the calcium, the iron, provide the exact chemical inventory required for biological organisms to emerge. Without the total destruction of these massive stars, the universe remains a sterile void of simple gases. Every physical body, including your own, is literally constructed from the shrapnel of dead stars.